Okay, right. So, I'm Nick Rossiter from visiting fellow at University of Northumbria in computing as background, but I've moved more and more into the philosophy area over the years. As you get more abstract as you get older. I think that's one viewpoint. And I'm going to talk about a formal basis for metabiology. Note the use of the word "a." I'm not saying this is the formal basis for metabiology or anything like that. It's really thinking about the subject and with some ideas from some very good workers in the past to try and make something of it and perhaps see a way forward. Right, so now do I do share screen?
Click on the green button.
No, but what are you?
There we are. There we are. Right, yes, so that's the first slide and done for ANPA. Since last talk to ANPA, where I talked a lot about Whitehead, I went 2 weeks ago to the 13th International Whitehead Conference in Munich and really presented the paper that's in the current ANPA proceedings, which was really modified a bit from the talk I gave last August to ANPA. And I had some feedback there, but I didn't get any vibes that I was completely on the wrong track with Whitehead. But there's some discussion about eternal objects, which I will come to later. Right, so motivation. Biology's always been the poor relation of physics when it comes to mathematical constructions. I think it's always been neglected. And but biology is such an important subject now. I think we do need to get a better handle on it, on the theory of it. And metabiology doesn't appear to have any clear definition, no pedigree, unlike metaphysics, which has a connection to Aristotle. But I stress now, it wasn't a term actually developed by Aristotle. It was assigned later to his work. And the reason we don't have any clear definition of biology is the perceived difficulty of describing the complex organisms and their transitions that underpin biology. So, and the lack of tools at the appropriate conceptual level. So I think there is a clear motivation. Whether we can actually get anywhere, a good solution is another matter. So one of the things I got the latest, one of the books with a grand title of Metabiology by Arturo Carcetti. And he discusses metabiology in terms of a number of features. It's got Husserl's phenomenology, sensory intuition, and categorical intuition. Now, a bit of category in there and intuition. That's very much into category theory, potentially. Gödel's sentences, Lauver's Cartesian closed categories, which we actually deal with later, but they come in more naturally from the work of Whitehead. Holmos's self-organizing intentional net with polyadic algebras. You can see these are higher level constructions, and Atlan's higher order cybernetics, self-organizing. Chaitin also coined the term metabiology, and Turing actually wandered into this area. He developed wave-like patterns for biology to are the chemical basis for morphogenesis. Well, I'm not actually going to deal with any of those in detail today. I'm not going to deal with them at all, really. I'm going to go on to two of my ideas, which which fit better with my categorical view of the world. But I'd welcome, if anyone's got any experience of those, I would very much welcome a chat later on why they might be better. So I'm not ruling them out. I'm just saying not. So the other works on metabiology which I've got interest in are Robert Rosen, who wrote the book Life Itself, where he deals with relational biology, and he uses actually category theory straight out to describe living systems. So I don't actually have to, I can adapt his work to perhaps more modern category theory, but I don't have to convert his work into category theory. So Robert Rosen, I feel, is one of the people who should be seriously considered. And the other one, not surprisingly perhaps, is Whitehead, dealing with process and reality, where he has these terms: prehension, which is seizing, grasping; concrescence, which is turning a virtual structure into a real structure; and eternal objects, which can be viewed as potentialities in the world, anything that can be created with a potential for being involved in a prehension. So a bit like types in computing science. So these are the two I'm going to consider today, but it's not exclusive for the subject as a whole. So the first thing is, what do we mean by meta? Because that obviously is quite important. And if you look at Wikipedia, I do look at Wikipedia for quite a lot of definitions, things like that. If you look at metaphysics, it's after, behind, beyond. If you look at Wikipedia for metadata, that's data that provides information about other data. And if you look at mathematics, so the study of mathematics itself using mathematical methods. So meta is, but then you've got chemistry, which is a bit of an oddball, because in the chemistry benzene rings, you have ortho, which right angles, meta, and para. Para is opposite. Then meta is in the middle. So between, which is another use of meta, obviously in chemistry. But as a chemist originally, I don't want to criticize chemistry for its choice of names, but it does seem to be the odd one out there. Okay, so metaphysics, let's look at that. Well, it's not a term coined by Aristotle. I know quite a lot of people think Aristotle did actually invent the term. He didn't. It's used by successors to describe a body of texts by Aristotle to be studied after the ones dealing with nature. And so it had the title of First Philosophy, Causes and Principles, and Being and Existence. Note that's the being and existence, which is a very key part of what I'm going to be dealing with today. So you can really consider metaphysics being more general and abstract principles, wisdom, after the physics. So it's after you've got the natural study of physics, you can rationalize it perhaps into more general principles. Metamathematics, the proponents here are Frege, Hilbert, Kleiner, and they were looking for foundations to mathematics to try and make it a lot easier to do proofs in future, generalizing proofs, meta theories, and but they ran into increasing trouble with this. Gödel's incompleteness theorems showed the limitations in proofs on axiomatic systems, and really metamathematics has been superseded by mathematical logic to some extent, one of which, of course, is category theory, which aims to coordinate different types of mathematics and enable them to be work together. Metadata, well established in computing science, it's mapping specific data definitions to general principles of data structuring. So if you've got a specific definition, you can relate it to tables and attributes and things like that. And it's essential for interconnection of systems. If you've got systems using different modes of operandus, then you can, like we call interoperability, you can link them if you've got metadata. And you can have multiple levels of abstraction. Meta is better is one of the sayings in object-oriented world, where you can go 2 levels up from the data definition into the top level definition is really the purpose of a particular construction, like what is a table, what is it actually doing. So that's very well established in computing. So going from those, I think we're obviously not going to use the chemistry definition, which is more in the middle. We're going to attempt to build a theory on general principles, abstracting from the specific, should be based on general processes, and that is a definite bias of the talk today. It's really based on process rather than structure. So I know we had the cell membrane in my corners talk as being the basis. Well, I'm going to encapsulate the structure. That's a common computing term, meaning I'm going to hide the detail of the cells, and so I'm going to concentrate on processes. So, but we can't ignore the organisms. Obviously, it's all based on organisms, biology, and any biological living system that functions as an individual life form. So all organisms are composed of cells. Cell theory could be a single cell or a composition of cells. Any individual animal, plant, bacterium having various parts or systems that function together as a whole to maintain life and its activities, or a form of life composed of mutually interdependent parts that maintain various vital processes. So the organism is the basis, obviously, of biology, but I'm not actually going to look too much at the structure of it, which you might regard as an omission. So relevant for biology, when we look at processes, this is a standard list that I got out of one source: movement, reproduction, sensitivity, nutrition, excretion, respiration, and growth. And you obviously have birth and death as well. And this important subject of evolution, which is the adaptation of organisms to their changing environments. So it can result in altered genes and things like that. I don't actually consider DNA, but I think that is could be an obvious addition to the talk, to look at DNA and how it influences the structure. That would probably be an improvement in the future. There's also anticipation that plays quite a big role in the natural world. Model will be able to accurately predict future behaviors of the original natural system. That's what Rosen has quite a lot on. So those are the processes. So we have mathematical properties, we have identity, assuming that the organisms are individuals, so they need identity. They have an internal structure, which I'm not modeling, as I said, as it's encapsulated, but I do have one or two ideas to look at that in the future, like DNA. So process is more important than structure from the viewpoint of today's talk. And as you probably won't be surprised, that leads into essentially a categorical approach with the arrow, the primary modeling construct. So that's going to comes from Rosen's work as he described it, and comes from Whitehead's work as we've converted his informal categories to formal categories. So that's the basic idea. So we got these two strong rival candidates for metabiology today. Robert Rosen, he had a fundamental look at biological systems in terms of life itself, and he also did a lot of work in anticipatory systems, because he thought that was an essential part of how biological systems worked. And he uses formal categorical functors. So he actually used category theory, and he had an appalling time when he first brought this in, because the category theory high priests, the pure mathematicians, said, you can't do this. Your types are far too ill-defined. You can do it with integers and reals and perhaps some other clearly defined types, but we're not at all happy with you using this, what you might call effervescent system of types with living creatures. And of course, that might be because you haven't defined the structure, but a pure mathematician would have said to Rosen, what are your types? And Rosen would have probably muttered a bit about he was dealing with it at a more abstract level than that. So he actually had some difficulties. I'll come on to that a bit more. Alfred Whitehead, in Process and Reality, develops for organisms a philosophy for being and becoming. So being is the existence of something, and becoming, or potential existence of something, and becoming is when that organism becomes concrete. So he has a two-level adaptation system for developing new organisms. The first stage is that you exist, but that then has to go through another process of concrescence before it actually becomes a concrete organism. He uses informal category theory, but I think it's pretty close to category theory when you look at it closely. Let's have another look at Rosen. 1934, 1998. Prominent theorist in the areas of biology and biophysics, Buffalo and Dalhousie. Interesting he was at Buffalo because, of course, that was also where William Lorvier, a very prominent category theorist, worked as well. So Buffalo has quite a good tradition. And he was influenced by Rashevsky's On Growth and Form, 1917 biotopology. So and he believed in complex systems. So he was very much against the idea that you could reduce, against reductionism and reconstruction. So he wasn't keen on reducing it to the parts and then reconstructing it again. He wanted to treat it at the surface level as a complex system. And he did not subscribe to Descartes' idea that animals are efficient machines. He thought there was more to it than that. He thought the complex system, the whole is greater than the parts, I suppose, is what he's really saying. And his complexity refers to the causal impact of organization on the system as a whole. Rosen did quite a lot of work on what he called MR systems, which is not in my list of activity earlier. M is metabolism and R is repair. So he's looking at the equilibrium in organisms between metabolism and repair. But he doesn't give many working examples of biological systems, so it was considered a bit abstract. And these were his publications: 1985, Anticipatory Systems; 1991, Life Itself, which is his best known one. But posthumously, there were two more published by his surviving wife and associates: 2000, Essays on Life Itself; in 2012, Anticipatory Systems was reprinted. So, he had quite a, what shall we say, crisis really in his lifetime, with the pressure, the criticism and pressures he got actually demoralized him to some extent, and quite a lot of his work was left in manuscript form, which was published later. So this is Rosen's modeling relation. You have a natural system here, and you have a formal system there, and you have these functors. So one is causality on the natural system, which is changing from one state to another. Encoding too takes it to a formal system, where you have inference as a self-referential process on the formal system, and then 4 is decoding, which takes you back to the natural system. So these are his quite simple ideas, and these he actually does define as functors. So this comes from his 1991 paper. Well, we adapted it a bit. I don't think we've done very much to it here, except there's one interesting thing here. If you have 1, the causality, and then you go through to the formal system and backward decoding, does 4 composed with 3 composed with 2 equal 1? In other words, does going through the model round the houses and back, does that what you might call compose? And so those are the functors he's got: causality, which he calls 1, encoding 2, inference implication 3, and decoding. Decoding is, of course, important scientifically, because that is the verification of the model, that you would hope that 1 equals 4 composed with 3 composed with 2, because that would say that your model was in perfect sync with the natural system. Well, I don't think many of us would. That's probably a bit ambitious, and he had a lot of difficulties in his earlier work in dealing with this composition problem, because people said, how can the hybrid diagram of biological and mathematical equivalences commute? So, oh, I hope that's not going to mean, it's because I've transferred it to PowerPoint. It might not have all the fonts. Does 1 equal 4 times 3? 4 composed with 3 composed with 2. With category theory, if it's equivalent relation, yes, it will do. And but category theory also enables us to have an approximation. So it doesn't have to actually be a complete match. It could be a joint, which is a different sort of relation. And Rosen resorted to various things like automata, which made his methods quite messy. And but so other people have used Rosen's work, and this is one by John Kleinman, and he's actually drawn another arrow across from the encoding to the decoding to show a relationship. And that's quite perceptive, because that's what we're going to look at, is the relationship between 4 and 2. So this is, we did some work at Liège in 2009 on anticipatory systems. And this is a diagram that we would use. 2 is the encoding, 4 is the decoding. That's the natural system, that's the formal system. We put them in Gothic letters, not to show off, because that's large categories rather than small categories. And so we've got a two-way mapping, and category theory has a lot to say with two-way mappings, because they may be a joint, the functors, or you would try and see whether they are a joint. The jointness being a very important property. So I apologize for this diagram. It's the one we had in the paper, and but this shows if you've got an arrow NSF to 4FS there, you can map it across with the functor 2 to give 2NS to FS. Then you can map it back. This is now called G, and you can map it back with 4, which is the decoding functor, to give this arrow here, which is called 4G and maps from 4 to 4FS. And so that's all a jointness is, really. It's a mapping from one category to another, and then mapping back again and seeing what the change is. So to put those arrows more into more detail, these are two very important measures. Unit of adjunction eta, that shows a natural system going over to a natural system composed with 2, which is the encoding, composed with 4, the decoding, to compare the result of going over and round the houses and back again. So if that is, if there's no change, then the relation is equivalent, which is the common one we have in set theory. But if there is a change, category theory can handle it. And this makes it a very much more powerful construction than set theory. And we see on the other side, the co-unit epsilon, we're mapping then from FS, where we applied functor 4 and then functor 2, and comparing it with FS. Yes, Sydney?
So the less strict equivalence, is that like up to isomorphism?
Yes, you're dead right. Yes, it still has to be some natural, it has to be natural. So it's unique up to some isomorphism. Yeah, that's right. So Rosen didn't actually do this. We've actually added this on, and 1 or 2 other people have worked on this. And I think if Rosen had applied a jointness, his work would have been more convincing, because people didn't really believe it was an equivalent, since no model is perfect. And so I think Rosen's potential is fundamental biological processes are modeled with its causality and inference to enable a comparison of biological causality with formal inferential modeling. And modeling can be anticipatory, and ideally inferences in model and natural causality give equivalence, but a jointness widens the scope of model to handle perturbations. So that makes it a lot more powerful. So, but we've added that last bit, and 1 or 2 other people have as well. Right, so let's now go and look at Whitehead. This is in Process and Reality, 1928, develops the idea of feelings. And this is based upon, if you really want to have a pithy summary, it's based upon concrescence, which is making something concrete, of conceptual virtual prehensions, from which prehensions are one structure seizing another structure, common to that, from ingression of eternal objects and actual entities. So it's quite simple, really, what his structure is. He does have this evolutionary idea, because you can have plenty of organisms formed, but they're not stable, because they're not being passed through, they don't satisfy concrescence. And that is really how I think Darwin's evolution worked. And in fact, that was one of the talks at the Munich conference I found very interesting, was the perceived influence of Darwin on Whitehead's thoughts. And it doesn't really acknowledge it, but it obviously we all take on other people's work unconsciously, from subconsciously, I should say, from time to time. And so we'll look at that in more detail. Whitehead doesn't claim that his feelings are conscious necessarily. He says they're sentient, so they can reflect senses. Prehension, which is a being, creates a being, does not necessarily lead to a concrete new entity, which is a becoming via concrescence. So he has a two-stage development there, and emergence and evolution are both covered by his theory, evolution from Darwin. So let's have a bit more detail with it. Entities are real, exist, individual, they're atomic, particular, so they're singled out, identity, and they can be joined together as a nexus, which is a union of similar entities, ordered society, and every entity should be a specific instance of one category of existence, so you've got classification as well. And entities can be seized by prehension, which is really this biological process, to give a subjective form. So prehension plays an essential part. So what are eternal objects? Well, this is where there's a lot of discussion at the Whitehead conference about these. Any entity whose conceptual recognition does not involve a necessary reference to any definite actual entities, they're definitely atemporal. They are really a permanent pool of objects that are available for use in prehensions. And I've got example, external objects are really potentials, which you can think of in type theory as being available to be used in instantiation. Could be an object like the number 2, so they could be just boring ordinary types, but they also include sensory qualities like colors, shapes, physical fundamentals, feelings, qualia. So these eternal objects have a very wide typing. They're not the typing you get in a normal computer program. And so these can give a conceptual prehension in the form of feelings. So eternal objects are there to be grabbed, seized by other objects to give apprehension. And this is Whitehead's idea of how biology works, very predatory. But Whitehead's a very interesting writer. He goes through pages of philosophy on a subject, which aren't too easy to understand. And then he suddenly gives a very pithy definition, like here, where he says that every prehension consists of 3 factors: the subject, which is prehending, the datum, which is prehended, captured, and the subjective form, which is how that subject prehends that datum. So that's actually Whitehead's words. And that goes quite clearly in category theory into a data relationship, and can be a pullback. And it doesn't have to be a times, it could be a union. So we can readily convert that into category theory, into a pullback diagram, where we have A, which is the subject that's doing the prehending. B is the datum that's captured. And D is something I've invented, because in category theory, you need a third object. And Whitehead doesn't have that in his work. And that is the subjective form, A times D in the context of B. So it's a relationship A times D in the context of B. And that's a very common structure in category theory. And one thing I can say at this time is that this could be captured by other objects. So this network, they're not just singular, these, there's a whole network of them with, so you can have one prehended object like that, and then that can then become, in another diagram, play that role and be prehended by other objects. So the whole thing forms a complex network. So prehension is a process by which an entity is captured. Becoming of an actual entity occurs through a concrescence of prehensions. And so that means that we have a lot of potential transitions, a lot of transitions to give potential entities, but they're not all viable. So you have to use, it's only when you get concrescence that the thing becomes real. And he calls this final phase satisfaction. So this is a bit like Darwin's idea, where you've got survival of the fittest, because some things will not be fit enough, and they're just there as a prehension available for capture, but maybe not realized. So that seems quite a plus point. So how do we actually adapt our pullback to handle concrescence? Well, I think we're going to bring in old friend Rossiter again, 1969, where we actually put some filters. We draw these lines. So we've got the same diagram with A, D, and B, but we've got these three diagrams which give a jointness between there exists the delta, which is the diagonal to the product, and for all the universal. So when you've got this adjointness between the existential and the diagonal and the universal, you have what we would regard as a very stable, well-defined structure, whereas before the structure was intermediate. So we would think that the hyperdoctrine of Rossiter, which is written at the bottom there, is what should apply. So to look at that, jointness gives viability. Whitehead, prehension gives relatedness, which is being. Concrescence give viability of relations, becoming. And in categories, pullbacks give relations, and adjointness gives viability. So I think that shows again the power of adjointness in structures. So what about these nexus? Well, a nexus is called a society. These nexus, they are really unions of entities, but they have a defining characteristic, which means that we have a type associated to them. So if you're going to define a society, you have to say, what is the defining characteristic? So for bird watchers, you have a bird society, defining characteristic might be that it's for bird watchers or something like that. So Whitehead has this idea, he calls it nexus. There is, of course, a nexus in Tyne and Weir, which is the name of the metro system, but whether that's related. But this again is well handled in category theory. We have, we can draw what's called a push out. So as the other one was times, this is a plus, a union. And so DC is the defining characteristic. S is a society. And then we can add the DC plus S in the context of INH. INH is a line of inheritance, which might give the order in the society or something like that, some further information. So with the nexus, we can represent those by what's called a push-out diagram. So far, there doesn't seem to be too much problem in adapting. So we have these prehensions, concrescence, and the nexus. What do we actually do with them? How do we represent the combined diagrams? Well, Whitehead does this with the category of the ultimate. where if you read this, the ultimate metaphysical principle, well, I'm saying it's metabiology principle really, is the advance from disjunction to conjunction, creating a novel entity. A novel entity is at once the togetherness of the many, and the many become one and are increased by one. And this is the important bit. In their nature, entities are disjunctively many in process of passage into conjunctive unity. So he thinks you can do disjunctive combinations of entities, and then you can apply to those disjunctive entities their conjunction. So you go from this plus to times in the structures. This is very common in category theory, tension between times and plus, conjunction and disjunction. And he also says here, yes, the category of the ultimate replaces Aristotle's category of primary substance. Whitehead had really a very strange relationship with Aristotle. He liked criticizing Aristotle, but in fact, a lot of the work he did was not too different from his. And so Aristotle's category of primary substance is extensional. So the topos here, well, the structure here is extensional, and his secondary substance is intensional, which is the defining characteristic in a nexus. So we've got using both intension and extension in this structure. So what does this look like? Well, there's a horrible diagram, but it really shows we start with the initial object, and which is the co-limit, and we can amalgamate nexus and the push-outs from the prehensions, the plus structures, all the way up to here. And then we can apply to these disjunctions conjunctions, so which is prehensions of the structures. So down here you've got nexus and push-outs. Up here you've got prehensions and concrescents. Yeah. That's an interesting point. I think there are quite a lot of other arrows on this. I think there should be arrows from here up to here, but I don't want to make the diagram any more cluttered. But it's a very good question. And so on the side here, you've got the disjunctions, many, and the conjunctions, many, and you end up with the one of Whitehead, which is the terminal object, the limit. So it's quite uncanny, really, how Whitehead's category of the ultimate is quite similar to a topos. So we're not far off now. Results 1. So the category of the ultimate is a topos, handling the process becoming. I think you'd assume that the conjunctions at the top are mainly concrescent. In a single substance philosophy, mind and matter are treated as one, and the match between Whitehead's language and topos theory is very close. He has some other special categories: existence, explanation, obligations, and they expand and control becoming. So process and reality is quite an amazing work, because it emerges out of nowhere. If you look at Whitehead's notes, Harvard notes, 1925 to 27, there's some inklings of these ideas, but they don't actually feature very strongly. And whether he thought they were too difficult for students or not, I don't know. I suspect he had it in the back of his mind the whole time, and rather like his own concrescents, he finally did concretize his work and bring it all into place. So yes, so that's results 2. Whitehead makes extensive use of some terms of his own, which we have related to category theory. So prehension, relatedness, that's a Cartesian, co-Cartesian, that's times for Cartesian, plus for co-Cartesian, closed category. Subjective forms are pullback, push out. Nexus, togetherness, is co-Cartesian, closed. Concrescence is a jointness, where you're bringing in locally Cartesian, closed category after Levere. Obligations, the underlying functor in a jointness. Satisfaction is the adjoint conditions realized, and category of the ultimate is a topos, Levere's hyperdoctrine. So, so that's basically that. So Whitehead's, what's the potential of Whitehead's work? Well, he certainly got emergence and evolution through prehension and concrescence. So if something's not viable, it's not fit, it's not going to get through concrescence. So it handles that. What about causality? Because causality would appear to be in Rosen's work and not so obvious in Whitehead's work. Well, prehensions can be nested. So with a subjective form from one prehension becoming the object of another prehension, giving subject-object pairs. So really he has a network of causality. He does handle causality, although he does use the word, but it's not that explicit. And part of the topos diagram earlier showed the nested conjunctives, where you've got the subjective forms becoming objects in further constructions. So it's pretty flexible there. So you're bound to come to the last slide, which is the better. And Rosen versus Whitehead. I have to say here, I'm not going to come to a firm conclusion. And I've always found that when you get into these, which is better, you have point scoring, whatever you do. If you have advocates for one side, they will always say, yes, my system can do this. You've just got to do that. And it's very complex. But from the biology viewpoint, both handle causality. Whitehead additionally handles evolution. Rosen additionally handles anticipation. So they've both got something additional to the causality. From the formal viewpoint, both are amenable to category theory formulation. From the meta viewpoint, Rosen has a simpler mechanism that's definitely easier to understand, involving model handling, brings in models more obviously than Whitehead. Whitehead's principles are not always explicit. You have to work quite hard to find out what he's actually saying. So from simplicity point of view, Rosen might be better. From the organism structure viewpoint, both are process orientated. So I am saying that the structure has been encapsulated, in other words, ignored. We're not going into the central part. So I've called it a score draw at present. I don't really want to come down on one side or the other. I think they're both great thinkers and should be respected for their work in metabiology. So I think that comes to the end. Yeah, it does.
Could there be a dual jointness between this?
A jointness between Rosen and Whitehead. That I was working on that on the train last night, and I decided not to risk it.
Oh no, stop the screen share.
So, oh there. Stop share. Right. I'm learning.
There you are. Okay. Talk away.
So these pipes are very fluid.
Yes.
They're not static, it's like dynamic pipe.
Yes, they could be considered that way. I mean, I haven't really the actual categories. I've concentrated much more on the functors than on the categories, and you could that is obviously an omission, and anybody has any ideas on that, I'd be quite helpful. But I was thinking that DNA would be one obvious way to, because that is like a coding, isn't it, for the structure. And so you could actually do something analogous with Rosen's ideas, where you've got the structure and then the encoding with the DNA and the decoding when you go back to the organism. So I think that would be my idea, preliminary idea for that you would use a similar structure to Rosen's, perhaps, with the DNA being the encoding. Because you do code with DNA, don't you?
So I understand. but then I think you need to have the epigenetics as well, which is probably quite nice in terms of category theory. Again, this balancing, it's because there's a like two-way thing, you know, because they used to think that DNA was the be-all and end-all, but they now realise that this is not the case. And
No, it's just part of the story, is it, the DNA?
yeah.
So yes,
yeah.
so but a genetics functor, genetics transformations, or is genetics a category?
You got me there. would you also send me your PowerPoint, please, Nick? You know,
Yes,
sort of,
certainly. Yeah, definitely.
I'm so glad you're coming to grips with category theory, Sydney, because I feel like Mike, Heather and Nick have both been very patient, like trying to help me with this, but then I go away and I don't do anything about it at all, so because I'm doing other things. So it's really great that in ANPA we've actually got still a thread of live category theory. So well done, Sydney. Thank you.
Yes.
I want to ask something about intention and Aristotle. So the also like, you know, category theory intention related to Aristotle. So is that like Aristotle's final cause?
Yes.
Right.
Well, I understand it. The extension is his first substance, and the intention is his second substance. But it might be the same as cause. I'm not sure they're synonyms.
Oh, he's got various causes. The final cause.
Oh yes, I'm with you. Yes, on his four causes.
It's like they're tied to Chardin.
No, I don't think they come from that. I think they're more.
Well, I was going to say, because one is usually a T, but whereas in category theory it's you know, it's intention with an S, and
Yeah.
So it is different. Yeah.
Yes, I think it is different. Yes.
Okay.
Yeah.
Are there any more questions?
Actually, well, I will. I mean, just in terms of, yeah, I was sorry I missed the Whitehead, but I had two other things either side, and it was just too much. And then with ANPA afterwards. So, but yeah, so concrescence. I'd just like you to say a bit more about it in terms of, you know, Whitehead and being and becoming.
Well, I think being is like a postulated structure. Where and it does not actually become permanent until it is until concrescence is applied to it, which he calls becoming. So you can have lots of these beings. Whitehead was very fond of potentials, and so these beings are potentials for becoming. So you can have lots of beings created, what I'd call pullbacks and pushouts, but they don't actually become proper constructions, viable constructions, unless they have this concrescence applied. So beings are like intermediate structures.
Please may I ask, is there any connection between the way Whitehead uses the word concrescence and the way Henri Bortoff uses the word concrescence?
I don't know. I presume there is. It means to concretize.
To join together, to unify in some.
Well,
Make a whole.
yes. With Whitehead's sense, it would be to permanently join things together. Yes, it's like a permanent construction, whereas a being is
Yes.
whereas a being is a temporary, possibly unstable construction.
Okay.
So I think it is probably similar. You know?
Another word is used, which is reification, which is the process of becoming concrete.
Yes, that's that.
But what was that, Grenville? I couldn't hear very well.
I've done a paper on reification, and reification is the process of becoming concrete. Another word you might consider.
Yeah, thank you. Yeah.
Yeah, because I thought, but you know, like I'm really not very knowledgeable. I'm not at all knowledgeable, but and this is really in a way from the conference I attended back in or whenever it was. When was it? 2019 19 or something, or ages ago, I thought concrescence was more manifestation, like the idea of human beings being concrescences.
Yeah, you could look upon it that way. It's really the final forms. So it's the final polished entities. I think that would be one interpretation.
Okay.
Yeah.
Does Rossiter say what there's one silent entity seems less as opposed to another one that doesn't?
Does he what?
Does it say what makes one silent entity become conscious when others don't?
Yes, yes. Some just stay there in limbo.
Does
Yes.
it say why?
Did you say why?
Yeah.
Well, it's really to give this evolution, I think. So some entities that can be created by prehensions aren't actually stable enough to be or viable enough to exist in the real world. So it means they don't satisfy real world requirements.
Like this.
Yes. So the beings obviously beings are always there as potentials for prehension, or sorry, for concrescence, but they may not all make it. It depends on the viability of them. Yeah.
So the citizens are the ingredients, the DNA is a recipe for the book of recipe.
Yeah, they're both. Yes, the being is certainly a recipe, really.
The being is the mirror. It's the genes of the totality of the individual.
Yes. Oh, yes. Total.
DNA is the recipe.
Yeah.
And the entity is the mirror.
Yes, I think that's right. Yeah. So it is like a recipe. Yes, the being, whereas the becoming is the whole. Yeah, I think that's a kind of good interpretation. Yeah.
Okay.
I'm wondering, this is a meta comment about the way we're doing this. Would it be possible for people who are actually present to come up and converse with whoever is giving the talk when they ask a question and begin? Because it's really difficult on Zoom to hear people from the actual audience. And I think, given that the whole idea of a conference is to confer,
Yeah.
people, on Zoom and in the audience can converse, as well as the person speaking in a way is a catalyst. I mean, it's obviously bringing something, but in the hope that more can come out, because that's what feeds us when we give talks. So this is just a suggestion. If people are willing to do that, I think it would make it a lot easier for us, the people who are on Zoom to actually know what's, to be more involved, really.
Or the speaker could repeat the question as they understand it.
Well, yes, but in just what's happened, there's been a conversation. So, I mean, it'll be very interesting for you to repeat everything. Anyway, it's just a suggestion.
Yeah. Okay.
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 Well, if there are no more questions, we will stop the recording.
Oh, yes.
And we'll have a 10-minute break before our final talk of this morning.